Hello, everyone. Thanks for coming here. This talk is faster data analytics with Spark using Solr, but I'm going to more talk about actually SQL. This talk is all about SQL. So for example, why SQL and why is it important to be able to do SQL queries, like all types of SQL queries on top of Apache Solr. All of us here come from different organizations. We all have a lot of mission critical data that lives in Apache Solr because of the speed, the flexibility, and the scalability of Solr. But if we take a broader view of the organization, only the search team is familiar with the data. All this mission critical data that lives in Solr, only the search team knows how to access this data, how to query this data. You can't have a business analyst or a data analyst point to a Solr instance and have them develop dashboards or have them develop analytical tools without teaching them what Solr is or how to query Solr. And this kind of makes an impediment learning curve for some people, and they kind of won't be even doing anything with the data. Whereas, and considering this in viewpoint, in Fusion, what we did is we developed a SQL service to which all the business analysts, they can use this service to discover, analyze, and visualize these data sets using any tool of their choice. This can be any SQL tool or any SQL dashboarding tool like Tableau. So this makes them not restricted to any certain framework. They don't need to learn how to query Solr, how to do query params, or get query params on Solr. So let's see, let's dig into this, what happens here. So before I start on what Fusion SQL is, first I'm going to show a fun experiment. I think I should credit Tim first. Tim Porter here, he orchestrated the Fusion service, and he did all the 99%. I'm just presenting here on behalf of him. So before we jump into what Fusion SQL is, let's see actually. So a few months ago, there was a blog post from Periscope on, so this, they had an SQL query, and they wanted to, they compared performance across 4 different popular SQL databases. And this is a very simple query, actually. What this query gives is, what are the dashboards that most of the users visited? And this is actually not just across all users. What are the dashboards that are visited by by the unique users? So here, if we take, there are 2 tables here. One is dashboards that contains all the dashboards and dashboard names. And another is a logs table that has all the records of each user visits. And the logs have, like, they have a dashboard ID and they have a user ID. Now, it's very common for analytical tools like Tableau and other tools to do this type of queries. It looks big, but the query is pretty simple. Give me all the dashboard names that have the most number of unique users. So here, if you take all this into consideration, like they compare performance, the query that I'm showing here is the query 3. Query 1 and query 2 are non-optimized queries. Here I'm just showing here the query 3. And when executed this against the Fusion SQL, it actually beat all these databases. And this is like on the first try. On the second try, caching comes into effect. It actually performs much better here. So what is Fusion SQL? So let's look at the overall picture of Fusion SQL. So Fusion has a SQL service that can be used to serve SQL queries by JDBC or via HTTP. As you see on the top left side, people can use dashboarding tools like Tableau, Zeppelin to do free-form SQL queries on this engine, or they can use HTTP API to send SQL via HTTP. And what is Fusion SQL? Fusion SQL is sitting on top of Apache Solr and Spark. It is getting best of both worlds, and in the middle, it is adding optimizations to both of this. So these optimizations, get us the best value from both engines. And we'll get deep into what optimizations are and the examples of optimizations. A question that we often faced across our organization is, why use Spark SQL? Why can't we just use Solr SQL? Solr SQL is fast, it does good, like why use it? Why don't you use it? Why do you need Spark SQL? The problem with Solr SQL is, it is good at what it does. It is very good at what it does because it uses Facet API, it uses streaming API to do all the stuff within this Solr clients and Solr servers, and there is no overhead because there is no third-party tool here. But the problem is it's very limited. You can't just have, for example, if we go to this diagram, you can't just point Tableau or any tool at Solr SQL and expect it to work. It actually fails. It actually fails because Solr SQL is limited. It doesn't support very free-form SQL, and it doesn't support nested joins. It doesn't support UDAFs. It doesn't support count distincts. And that's the problem with Solr SQL. So for example, just to show an example, I don't know what this query does, but there's a benchmark called TPCDS benchmark. So the TPDS benchmark data set has a set of 99 SQL queries. And this de facto standard, it is used to measure SQL performance and SQL power across big data SQL engines. Now, if I run this query against Solr, it will fail, because Solr doesn't support any free-form SQL here. Now, I also have a small demo here where I've plugged in, one second, let me see. So I created a notebook here with Solr JDBC. Here, this is just, sorry, I think you can't say. This place. I think you can see now. So here I created an interpreter called Solr JDBC interpreter with just connecting to Solr SQL here. It just connects to Solr SQL via JDBC using the Solr J client. It's very simple. Now, if we go to the notebook here, the Solr JDBC test. Here I'm just doing a simple SQL. It works fine. Here I'm doing the TPDC query, which is the benchmark query to test how good a SQL engine is, how good of a language, how good of a syntax it supports. And this query fails with Solr SQL. For example, anything simple like select star, this is just basic SQL query, and it fails with Solr SQL as well. And the power of Solr SQL is it lets you do full text search. You can't do it with any other JDBC engines. Because the primary reason we use Solr is because of full text search, right? You can do, so using Solr SQL, you can do text queries, like give me all the documents that have this phrase called dog. And then, for example, it fails when I try to do count distinct queries, as shown here. So the problem is, it's good at what it does, but it is pretty limited. It doesn't give us many options. So we kind of, to get the best of both worlds, we marry both of these. We marry Spark SQL and Solr SQL, and we build Fusion SQL on top of this. So that way, we have a query language that is supported by all tools, that supports all queries from all analytical tools, and also we get the best from Solr, where everything runs within Solr, the things that Solr does best, and we get the best from it. Oh, too fast. Okay, if you see what Spark SQL is, so in general, if you're not familiar with Spark, Spark is a very fast in-memory distributed data processing engine. It has a lot of components, and SQL is one of its most popular components. And even Spark supports all those, the scary query that I showed you. Like, so even like it took like 4 releases of Spark to actually support all the 99 test queries in this benchmark data set. Currently in Spark, it can run all those 99 queries. And it has a lot of optimizations that are present inside. It can run SQL queries on files. It can run SQL queries on Hive tables, on JDBC, or across any Spark connectors. It can run SQL on S3 and stuff like that. Now, how this SQL engine works is it works in four phases. So the first phase is it gets the SQL query, and then it has an unresolved logical plan. From this logical plan, it resolves the references. Once it gets the references, it will optimize the logical plan. Once optimized, it will develop many physical plans. And based on the cost model, cost-based optimizer, it will select one physical plan to execute. And this physical plan, it is compiled into JVM bytecode and sent across various nodes so that when each row is processed in all these tasks, it won't take much time to actually evaluate the expression. That's why the whole stage code generation is one of the big features of Spark. Now, how does actually this work? Like, how does Spark even talk to Solr? So Lucidworks has an open source connector, Spark data source connector that connects Spark and Solr. You can read, write data to it. You can do like, you can retrieve data very fast. You can write data. You can use, it uses export handler. It uses select handler based on the fields that you're querying. It uses schema API. It supports authentication and all that stuff. So we use this in Fusion to actually talk between Spark and Solr. So let's come back to this experiment here. So what did Fusion SQL do that made it execute this query so fast. So if we take just this query in general, so it is doing a join across two tables. From the logs table, it is getting the distinct queries by doing a group by on the dashboard ID. And then it's doing the join across. So what we do in Fusion SQL is we don't let Spark execute this query fully. So we take the subquery that is within the join, and then we take the subquery and then transform into a streaming expression. And the streaming expression, it's actually pretty simple. It does a facet with two buckets, and then it does a roll-up, and then it gets a field, and then we sort the field. So this streaming expression is actually pretty fast in Solr. It executes super fast. And so what happens is, so when Spark gets these two queries, it will divide these two queries. And then the second query, we transform it as streaming expression. It gets these results, and then it joins. By doing this joins on very small data sets, we actually make it pretty fast for this query to finish. So that's one example. That's why we were able to achieve that speed, because we are able to transform into different expressions. So for another example is Fusion SQL. So for example, like with SQL, you can't do like full text queries here, like using Fusion SQL. This is one example. So here on the top, it's just a SQL query where you're just querying on a Solr field and you're searching for the term dogs. But below there, what happens is this gets transformed into a Solr query with the appropriate fields. So for example, here, this is transformed into a Solr SQL query. So all this optimization and transformations are done based on the type of query that is performed. So here, this Solr SQL supports these queries, so we are just sending it to Solr SQL here, and then it all works. So, and another kind of push down that we do is optimization that we do is currently like, for example, if you're doing filtering based on timestamps, we don't need to, so usually what happens when Spark processes queries is, it gets all the data, and then it does all the filtering on its own. And it's actually an I/O overhead, because Solr supports these simple filters using filter queries. So like what we do is we take this filter timestamp, and then we push it down to Solr. So Solr actually only returns the number of rows as needed. So we actually avoid the extra filtering that is done by Spark here. So if we take Fusion SQL here, so you can also, Fusion SQL, our users can do Solr SQL inside Fusion SQL. So here what we are doing is we are executing a query, SQL query, as Solr. What it means is it is executed as a Solr SQL. So down below, what we do here is we transform it into a SQL query, and then we send it to Solr, and Solr gives us the results back. This way, the actual execution, the actual processing is done inside of Solr and not in Spark. We only do it in Spark where it's needed, and we don't do it, and we push it to Solr as much as we can. That's always our goal to do here. And I want to talk about another Fusion feature here. So there is a Fusion feature called time partition feature, where based on the incoming timestamp, users can enable this feature on a collection that lets documents be put into various time partition shards. So the advantage with this is, for example, someone has like firewall logs or normal user logs. Usually people don't query, usually the queries happen on the most recent logs, and it doesn't always happen on all the shards that have all the timestamps. So for example, here the user is actually not aware of all the time partition collections. They're only aware of the top thing called event sim. And event sim is just a logical collection. It doesn't hold any data. It just points to a payload there. So what happens when user queries this thing called event sim, and they say, oh yeah, get me all the documents that have this timestamp above this. So we don't actually go to all the collections here and do the query. We only go to the collections that have this data, that have the data above that specific date range, and then that's what we use. And then I'm going to show you here a Zeppelin demo. So here, the one we have here, I was showing you Solr JDBC test, right? Now I configured another interpreter here, which is Fusion SQL interpreter. As you see, here I have configured the interpreter to the Fusion port, the port that runs the Fusion SQL on. I don't think you can see. Yeah, so I just configured the username, password, and then I configured it to the SQL server that is present. And that's pretty, and then I've added the shaded jar that is shipped with Fusion by default. And by using this interpreter, I'm going to do SQL queries through Fusion SQL. So for example here, the query that I was showing you before, it actually, let me explain the data set before doing queries here. So anyone who is not familiar with, this is Fusion UI here. I have several collections indexed here with just random data. So for example, movie lengths, the collections related to movie lengths here are movies, ratings, users, and zip codes. And some of the other collections are related to the TPC data set. So let me actually show you what the data looks like inside these collections. So inside movies, I have a movie ID, movie title, and then all other metadata here. And then inside ratings, which is just ratings from the user, right? I have the rating, I have the movie ID. If you see here, it doesn't have the movie title. It only has the movie ID. And then it has a user ID and then the rating that was given by the user. So in this query here, what I'm doing here is I'm getting the movies that are rated by that are rated by unique users. So for example, here the title, the movie Fargo, is rated by 508 unique users. And how do we achieve this? So for doing this, we got to query the movies collection because we need the movie title. And then we got to join it with the unique data that comes from the ratings collection. So here, if you see this one, we get a distinct pair of movie ID and the user ID. Then we group with movie ID. And then we get the count of it here. And then once we get it, then we associate the documents. We do the join based on this, and then we sort by the count. So here what it gives is, it gives the movies and also the unique number of users that rated this movie. And let me actually show you like what Fusion does good here. So this is the Spark driver UI that is running on 4040 port. So if I go to this place, and let's actually look at, so when Spark gets a query, right, it makes a logical plan, and then it does a physical plan out of it. So what we are doing here is the DAG that is executing this query. So it has two queries here. One is the join query. One is the query to the ratings collection. One is the query to the movies collection. Here on the left side, we have the one that is coming from the movies collection. It is getting a total of 1,600 rows from Solr. On the right side, what I have is this count distinct pushdown query. It is actually a strategy that was added to Spark by Fusion, that added to SQL context by Fusion, so that whenever it sees a count distinct query, it transforms it into a streaming expression, and it tells like execute this streaming expression and give me the rows out of this streaming expression. So here Spark gets this 280 documents from these streaming expressions, and then it does the join here. And also like there are always more details on what's going on inside the query. So for example, like what's the logical plan with all the references solved, and then what is the analyzed plan, and then what is the optimized plan here. And at the end, as you see, there is a physical plan. So physical plan is where we marry all of our extra strategies to Spark. So when it sees things like this is a count distinct query, then we tell like, oh yeah, Solr does this better. Solr does this better by streaming expression. So that's how we add this to Spark. So let's go back and try more queries. So for example, here I have just a simple count query. Usually how this works in Spark is like Spark gets all the data, and then it does the counts, and then it does the aggregates. But this is very easy to do in Solr. You can do a query, and then you can get a num found to determine how many documents are there in a collection. So by using what Solr has, so we run this query, and then So here we plug in our strategy called count Solr pushdown query. It actually makes Spark not get any data, but it just gets the num found by going to Solr and returning the data to Solr. Here, this is a simple full text query that goes into the simple full text query, and whenever whenever our engine sees a query like underscore query underscore, we send it to Solr SQL, and Solr SQL executes the query inside the SolarJ client and Solr servers, and then it returns the data back. So here, if you see, I'm doing a query on logs collection with a specific timestamp. So now, if we go back to the actual query that was executed, this query goes into this Fusion SQL optimizer. It finds the timestamp fields and it applies the ranges on all these queries. By pushing this down to Solr, as you can see here, by pushing down to Solr, we actually let Spark do less work and Solr do all the filtering. So this is, let me zoom in a little bit. So yeah, this is give me just the movie IDs. This is an example of just how to send a SQL to Solr and not let Spark do anything. So this is SQL that works with Solr. So our customers can specify, if they specify as Solr, we will just push it to Solr SQL and let Solr SQL do all the work here. And Spark just returns the results here. And also like these simple commands like, so for example, show tables. So if you see here actually, if we see in Fusion, there are not, for example, here we see a table called min users, but there is no actual table called min users anywhere here, anywhere inside Fusion or anywhere inside Solr. So going back to this, now why are we seeing an extra collection here? Because we have this thing called catalog API that lets you create views and save these tables. So even if the collection does not exist, you can create a view of it by using our API and then get the table loaded automatically. So as an example of this, so for example here, so I create an asset here, which is a part of the catalog API. And then in this asset, I'm naming the table. And another important thing is I know this table is very small. It doesn't make sense to read this table every time when someone queries. So since it's very small, I'm going to tell Fusion SQL, load this table on every time, cache this table every time you load the SQL engine. So by caching, we are not going to Solr every time doing the IO overhead. We are just keeping it in memory. We are just utilizing the best of everything here. So by doing this, anyone can query on this table, get data, and do complex things. Oops. So this is another inner join example on the movie lens dataset. And this is doing inner join across movies and ratings collection here. And this is another advantage where user actually is using Solr to do the geo-filtering queries. So they're doing the geo-filtering queries, and with this actually the geo-filtering query, how it works is, because of the tag as Solr, this geo-filtering query is sent to Solr. Spark doesn't know what to do with this. Spark doesn't know how to do geo-filtering, I think. But Solr does this really well. It knows how to do geo-filtering. So we are letting Solr do the heavy part, which is do all the geo-filtering on this query, and then return back those results. Once I get those results, I'll join it on the other table, which has all the data. And this is the TPDC query, the one I was showing you, where like this is the standard. This is like one of the 99 queries that were used to determine like how good a SQL engine is, how scalable it is, how good it is performing. And this query works in Fusion SQL. And this query works in Fusion SQL fine. I don't know what it does, but it does work in Fusion SQL. I just want to show like, because of this, so you can have your tools, any tools in your organization that can do SQL analytics, you can just point to Fusion SQL and let it just work. You don't need to worry about what's happening here. Optimizations take care of automatically. So for example, if you have a data scientist or someone who knows how to do SQL, or a business analyst who knows how to use Tableau, they don't need to learn Solr, or they don't need to learn Solr query language or anything. They can just do these SQL queries, just gets the data from Solr. And in between, you can have your search engineer do these complex views that the data engineer doesn't need to be aware of, any kind of transformations or any kind of complex views. And let it do all the work here. So I think, and also, okay, going back 1 second. So for example, like in case you want to do it on your own, how to add actually these extra strategies? Because even, for example, you can just talk to Spark and Solr by using Spark Solr repository, but it doesn't come all this with extra strategies. Extra strategies are something that we added only in Fusion. So for example, if you want to do it on your own, how to add extra strategies is just a sample example, a pseudocode, which I want to use, like just say like, okay, for SQL context is the entry point to do anything in Spark. So what I'm doing here is when I create the SQL context, I'm adding all these extra strategies. And what does the extra strategy do is it takes a Spark logical plan and then converts it into a Spark plan. And inside the Spark plan, you can do anything. And this code is written in Scala, actually. That way, you see the Scala matching. Scala matching is pretty nice, actually. You can't do this in Java. It doesn't provide us that flexibility. It'll look very ugly as well. But using Scala, we can do all this fancy matching, fancy type matching, which we can use, say, okay, if this is of a type count. So here, it doesn't look like SQL query. These are just like Scala classes. Here, if this class is of this type, then, okay, I got a count query. Now do a Solr query on this, get the num found on this, and return a Spark plan object. And using this Spark plan object, next time, every time the user runs a count query, it goes through this, it gets the data from Solr, and then it returns the data back. Since you have a little bit of time, I just want to show like another open source example. Like currently, with just Solr and Spark, you can use the Spark Solr data source to do SQL queries just by using the Spark Solr open source repository. So like what you do is you create a table. How do you create a table is you actually create a data frame first. Once you create a data frame by using a Solr collection, you have to register the data frame as a SQL table. It doesn't do automatically. So you have to register it as a table, and once you have it as a table, it does, and you can do SQL queries using this. This repo is open as well, so you can all like try out how it is. But this doesn't have any of the strategies or optimizations that I was talking about. This just does like how it works is it does it for every query. It goes to Solr, gets all the data, and lets Spark do everything. That's how it works in the Spark Solr repository now. I think that's pretty much it. If you have any questions, yeah.
Where you had query underscore query equals plot text en.
Yeah.
I think you can just do plot text en equals and then.
Oh yeah. This was an old example, right? Yeah, this old example. Yeah.
Detect that that's a text field and it'll actually do a full text search.
Let's do a live demo. No, I don't want to mess with that. So okay. Yep. Now let's see what happened here. So if you go here, it goes through the optimizer. It doesn't go through plain Spark. So kudos to Tim for adding that. Sure.
So you only have a condition you have query if you run Spark SQL, it doesn't go to Solr to use the condition. Even if the filters doesn't apply filter to Solr.
With the Spark Solr, basic filters will work. But for basic filters like non-timestamp filters. So I have actual examples here. So the question is, with Spark SQL, with just Solr and Spark, does the filtering not go down? Does the predicate push down? Do the predicate push downs go down or not? So here, like this is a simple filter, right? So this, by using just Spark and Solr, by just using the Spark Solr repository, these kind of filters always get pushed down. So for example, language equal to English, or like any kind of normal filters. But the caveat is like the timestamp filters actually don't work because at a higher level, Spark doesn't push down the timestamps down to Spark Solr. So by going more low level, we actually get to utilize we actually can determine whether the filter is happening or not. So for example here, user is doing a filtering on get me all the timestamp logs after August 31st. But what Spark Solr gets is it doesn't get that filter. It only gets the non-null filter query. So in this example, if you see actually, by just using Spark Solr, so there are a total of 5,800 rows that came from Solr. And Spark did the filtering on its own based on the timestamp. And Spark determined, okay, after the filtering, there are a total of 3,100 rows. So the query will work always with SQL, but the problem is where it happens. So is the filtering happening in Spark or is it happening in Solr? And these optimizations help us improve the query performance. For timestamps, what it does is because of the way timestamp queries can be formed, and also I think because of the, so basically timestamp, even though it's a date type, Spark caches as a string first, and then because of that casting, it is not able to push down at a physical level, physical plan level. I think filtering pretty much all other simple filters are pushed down. Timestamp, I don't think it's pushed down. I mean, for example, if you're doing a full text search, it's not. So for example, if you do a full text search, like for example, if you do this in Spark, right, just Spark Solr, this is not going to work because Spark is going to think, okay, I'm doing a filtering myself. So Spark decides to do the filter itself, but this is a full text search. It's a big text field. It has a lot of terms inside rather than dogs. So like Spark is going to fail with it. Tim can correct me here.
No, you're right.
Spark will just fail.
So this is where we've taken a little bit of liberty and said, well, we know you're talking to Solr, and we know that plot text the end is a text field. So you probably really want to do a full text search here and don't just want plot of dogs, right? So we basically look at that and turn it into the right Solr query. If you just give that to Spark without the query plan plugin that Kiran showed, it'll just basically, excuse me, it will essentially expect every row that comes back from Solr to have a plot exactly equal to dogs. So that's why we had to have like tricks like this.
Yeah, it's.
But again, we know it's Solr, so
Yeah.
we kind of take some liberty in certain cases around full text search because usually when people are hitting Solr, that's kind of what they expect versus equivalence here.
Yeah, it's sure.
Since the join to the different factoring inside a Spark, I assume you can join number of joins, any number of joins.
Yeah. So the question is, can you do any number of joins inside Spark? Yes. Yeah. You can. So these basically are tables or Solr collections, right? Inside Spark, you can do as many joins. You can have like very complex SQL queries as well.
Does Fusion SQL support other languages like Chinese, Japanese?
So the question is, does Fusion SQL support other languages like Chinese, Japanese? It actually kind of goes down to Solr actually.
Yeah, I would imagine. Like
One second.
word calls and things like that, yeah, that should be fine.
So in Spark Solr, in the open source repository GitHub page, we have a version compatibility. We have a version compatibility table here. Then like, yeah, every release I add everything here, so don't. No. So Spark Solr is open source. You can just use with Spark and Solr. You don't need Fusion for it. But to get, yeah, Fusion SQL is like, it's Spark Solr with the optimizations that I was talking about. You only get the optimizations if you use Fusion SQL, but you can just do SQL with Spark Solr, like, because this just adds a Spark data source. You can just do any Spark SQL queries on this. It's just that you don't get the optimizations that we added in Fusion SQL if you use Fusion, if you don't use Fusion SQL.
So can you explain the difference between the parallel SQL interface that Solr offers and Fusion SQL and Spark Solr? So what is like the main difference?
So Spark Solr, as I was showing about, let me actually show you. So sorry, the question was, what's the difference between Spark SQL and Spark Solr and Fusion SQL? So let's, yeah, parallel SQL, that's what I mean. Yeah, that's what I was telling about. That's the same thing. It's a Solr SQL, yeah. So Solr SQL, there are a lot of limitations. You can't do like just general SQL queries that any dashboard does here. So it's actually it's pretty good at what it does, but it's pretty limited here, pretty limited in the number of options. If I run any of these queries, it'll just fail. So for Spark Solr, as I was showing, I think this diagram will show much better. So with Spark Solr, with just Spark Solr, you don't get the optimizations there. You don't get all the optimizations that I just talked about. With Fusion SQL, you get the optimization. That's the yeah. So it's about so like when it's depending on the amount of data, right? So if you have a huge volume of data, just reading the data into Spark takes time. So letting Spark do everything, the problem is like the IO overhead and then just getting the data. By pushing down to Solr some of these queries, we actually get much better performance. Yeah, so you can write spinning expressions. So I was showing you, right, in the catalog REST API, you can create tables out of streaming expressions. So here what happens is when we spin up the SQL service, which is a thrift service, which is nothing but Spark thrift server, when we spin it up, we add the extra strategies to the Hive context. So this is happening when we are booting up the SQL service. So this doesn't happen during the job run, but it happens since we are adding the extra strategies to the Hive context just when it's booting up. Whenever a query comes here, it'll just go down through the extra strategies that we add here.
Can you just, sorry, go to the first slide?
Okay. First, this one?
Yeah, with the Fusion is faster.
Oh, yeah. Sorry. Sure, yeah. So the question is, how is the performance of Solr affected? Because Spark reads a lot of data from Solr, right? So it depends on the fields that are queried. So for example, Spark Solr, it tries to use the export handler as much as possible. The best thing with export handler is actually, the data is read pretty fast. I think, Tim, did we have like 1 million rows per second or something? Yeah, we were able to read data at a speed of 1 million rows per second using the export handler. So if it's going through export handler, it's pretty fast and it's very light load on Solr. It's actually, surprisingly, it's very light load on Spark as well. Because by just using minimum number of tasks, it can just grab all the data. So so the question is like, how do we control the number of partitions that come up when a Spark job runs through Spark Solr? So yeah, all these, like, we have options, pluggable configurations to change all these things, and all of this is present in the GitHub repo. I think it's called splits per shard.
Quick question. Could you show us in Zeppelin how you pointed to the Fusion SQL endpoint?
Sure, yeah. Interpreter. Can you see? Yeah. So I'm giving the user admin password. This can be anything. I mean, this can be any different user in Fusion. Here, sorry. So here I have SQL service running, right? This is SQL running inside Fusion. So here, this is the path. This is the URL that you have to use in Zeppelin interpreter to let it talk to the Fusion SQL server. Yes, yes. So this goes through the Hive JDBC connector. Yeah, slides will be available. Fusion SQL is not open source. It's our enterprise product, actually. Sorry?
It has to come with the Fusion.
Yeah, it comes with Fusion by default. It has been there for past 2 versions, 3.0, 3.1. We are getting out the beta tag on 4.0. Sorry, I think we can talk here. We're done. Time is over, but we can.